Hey, welcome back to Math with Patrick and Quill. Today is December 17th, and we're solving problem 351 from the Daily Epsilon calendar. And for today, the answer should be 17 because that's today's date. All we need to do is find the discriminant of this quadratic expression. Now, just kind of like the definition of the discriminant is that it's b squared minus 4ac. This is a part of the quadratic equation, which is going to be all of this nonsense. And it's the part that lives underneath this square root sign. And it's a useful thing to know when you're working with polynomials, because if we have a positive discriminant, let's say we have 9, then this suggests that we have two solutions out of our quadratic. We can see that it'll be added or subtracted to the other values in the expression, and that will produce two answers out of our equation. If the discriminant happens to be 0, then when we add and subtract 0, we're not really doing anything different. And so the discriminant being 0 is an indication that we have exactly one solution out of our quadratic. And if we happen to find a negative discriminant, we would need to use complex numbers or imaginary numbers to start finding some roots or solutions for these equations. So a negative discriminant implies that we need complex roots. Anyways, that's what it is. That's what it's useful for. For today, all we really need to do is plug in A, B, and C into the formula and figure out that it's 17. A is the leading coefficient of our polynomial, and since there is none, it's going to be 1, because 1 times anything just keeps it the same. The B value is the second coefficient, and so that's going to be -3 here, then squared. Those parentheses are important, because if I just wrote -3 squared, that would suggest that we square the 3 first, then make it negative, and that's not what I'm doing. I want to take -3 and then multiply it by -3. And then finally, our C value is this last value at the end. It's at -2, so I'll pop -2 right here. We get 9 minus, and then this is a -8, which is the same thing as 9 plus 8, which is 17. Cool. So that's today's date. We're all done, but feel free to stick around though, because I do want to show where this is even coming from. To prove where this is coming from, I essentially just need to prove why the quadratic formula works. And what I think I'll do here is I'll have just a normal looking polynomial over here and a general standard form polynomial on the left. And whatever steps I'm going to take over here, I'll try to take over here with the variables instead of my constants over here. So if I wanted to use the completing the square strategy on the right side, first, I do want to make sure that my leading coefficient is 1. And the first thing I do here is just divide everything by 2. I can also divide the 0 by 2 on the other side. And it lets me simplify my quadratic equation a little bit. And again, the goal was to get a 1 at the front. So on the left side, I'm dividing everything by this a value, and I'll get x squared plus b over a times x plus c over a is equal to, well, it's 0 over a, but I could just call that 0, because 0 divided by anything is 0. And I also know that this a value isn't 0 itself, or else we wouldn't have a quadratic. The next step that I take is I try to figure out what half of this number is, because when we do the completing the square process, we take half of the b value and stick it right there and square it. And I'll deal with the rest in a sec, because I want to go over on my left side. I know that I will have x minus and then half of this value. Or I guess in this case it would be plus, because I'm keeping the same sign. So I'll go plus b over 2a, x, and then square it. And I don't need the x, because that is not what I had on the right side. Cool, so I'll square it. And then now I need to figure out what's happening with the rest of my right side equation. Currently what I have is, if I expanded this out, I would have x squared minus 4x and then plus 4. And I only have a plus 3. And so to compensate, I need to subtract a 1 off of this. And the idea here is we could see that just this expression right here has an extra 4 that came out of nowhere. Well, it didn't come out of nowhere, but it came out of squaring -2. And I need to subtract that value to make sure that I'm keeping things all the same. So this -4 on the end is compensating for the fact that I essentially created a +4 on the inside. And to produce a -4, I am squaring my value right there. So I should take b over 2a, square it, and then subtract it off the end so that I can maintain my equality. I still will have plus c over a equals 0. And then this term right here helps me maintain equality and basically cancel out that term. On the right-hand side, I can just combine that +3 and -4 as a -1. But I think so that I can keep a comparison going between the two different expressions, I won't. Next up, let's isolate this x squared term. So I could use opposite operations and move that +3 and -4 to the other side of the equation, keep this x minus 2 squared. And on my left side, I will keep my squared term the same, and I will move to the other side of the equation the other kind of constant terms, I suppose, on the end. So I'll get b over 2a all squared minus c over a. The next step to try to isolate x is to square root both sides. So I'll get x minus 2. And then when you are the one to introduce a square root in an equation, you do need to also introduce a plus and minus sign. The idea being, if we just check like an easier example, x squared equals 4, there are two possible values that x could be. It could either be 2 or it could be -2. So if you square root both sides and just look at, oh, cool, the square root of 4 is just 2, well, you're missing out on half of the information. In this instance, x could have also been -2. So I always like to remember, if I'm the one putting the square root there, I need to also put the plus and minus sign. And here we're basically done, but let me flip back to the left side just to make sure that I'm keeping everything straight. We will get x plus b over 2a. Then this is going to be equal to plus or minus the square root here, which will be b over 2a squared and then minus c over a. And the last thing to do to solve our quadratic equation to isolate x would be to do the opposite operation of this b over 2a. So on the right side, I can just add 2 to both sides. And at this point, I would just simplify this square root expression. It's just 1, or the square root of 1, which is just 1. And then we can go even a step further and say that, yep, okay, cool, x is either going to be 3 or x is going to be equal to 1. Now, we aren't going to have those simple simplifications on the variable side because these are just variables. I can't combine them as readily, but I will still try to make some simplifications. Let's isolate x. So x equals -b over 2a plus or minus this whole thing. And technically we're done, although this doesn't quite look like the quadratic formula just yet. And what can we do here? I think I want to find some kind of common denominator. Maybe I want to factor out this a. And again, my goal is to prove that the discriminant is just b squared minus 4ac. So I think what I'll do here is to try to find a common denominator, I'm going to take my right side and multiply this by, let's go 2a on bottom, and then the square root of 4a squared on the top. Now, these two things are both the same on the top and bottom. I mean, granted that a is positive, and I think I can assume that a is positive just because at our very, very start, we could divide or multiply by a -1 to guarantee that a is positive. So I'm fine there. This lets me get a common denominator going of 2a on the bottom. The -b can go here. And then now I should just multiply this 4a squared, or I guess the square root of 4a squared, in with the square root of whatever I had originally, b over 2a squared, and then minus c over a. You can multiply the radicands together. Like if I had root 2 times root 3, this is just the same thing as root 6. So I can go the square root of, and then shove in my 4a squared and see if I can distribute anything to my other two terms. I should be able to, right? Because this should simplify to the quadratic formula that we recognize. Here, I'll do this distribution first because it looks easier. There isn't that square that's kind of making things complicated. I will get 4a squared times c on the top, then divided by a on the bottom. These cancel, so I do see my minus 4ac coming together. And then distributing the first two terms, maybe let's also distribute the square. Okay, so we get b squared, and then on the bottom, we would get 4a squared. Ah, perfect. Because then once we multiply in the other 4a squared coming in, these two cancel. And so finally, we do get this b squared minus 4ac underneath the square root sign. So now that we know that multiplying this 4a squared into a radicand essentially creates the quadratic formula that we already know, we're done. This proves where the discriminant is coming from, right here. And you can know why it works by knowing how to derive the quadratic formula yourself. So that is the end of the video. The answer is 17 either way, but I did want to show where this expression is coming from. So thank you for watching this video. I hope you enjoyed, and we will see you tomorrow. Bye.